if I go on and start that. What we're looking at today is multiplication, division, and complex rational expressions, or complex fractions. We're going to look at multiplication, division, and then we'll get into a few of the complex fractions. Today we'll have to finish it up tomorrow. Now the first one we're looking at is this here. We're multiplying by two rational expressions with monomial terms in the numerator and denominator. There's only one term. So when we look at the numerator with these rational expressions, we go on and multiply them together and then simplify down. We could simplify at this point, but I think it might be a little bit easier to keep everything straight if we just multiplied first. So we multiply first 3x squared times 4y cubed. Well, we can do 3 times 4, which is 12. Now, since the x and y are not like terms, well, we'll just multiply together as x squared and y cubed. As if the terms being multiplied together are the same, so x and x, we would add the exponents. But since they're not, they won't change. Now we can do the same thing with the denominator, 2y and 3x. Well, our 2 times 3 would give us 6, and x times y is, well, xy. Any questions on this so far? Now that we have it simplified to one term and one term, we can go on and simplify. Well, 12 divided by 6 is 2 over 1, but we'll leave the 1 for now, because if we'll have everything in the denominator simplifies, we don't have to write a denominator. Now the next one we can look at is the x squared over x. Yes, and would it be on top or bottom? Top. Because one of the x's on bottom will simplify with one of the ones on top, leaving us with just 1. The other way we can look at it is we can subtract the exponents. 2 minus 1 is 1, and since it's bigger on top, it'll stay on top. And lastly is y cubed divided by y, which would be y squared. And since it's bigger on top, it'll stay on top. And that's it. As with the y's, one of them is simplifying. One of them simplifies on top and bottom, leaving us with just y squared on top. Or we can say that 3 minus 1 is 2, and since it's bigger on top, it'll stay on top. But that's it. Any questions on this here? If we wanted to, we could have simplified it out at the beginning and saying that this 3 and this 3 would cancel out. This 2 and this 4 would simplify to 2. This y would take this down to 2. This x would take it down to 1, leaving us with 2x y squared. But it's sometimes easier if we multiply it together and then simplify. Any questions on this here? Okay. Now monomials aren't too bad, so we can go on and work with polynomials because that's most likely what we'll be doing more with. So here the x minus 5 does have a denominator of 1. Whenever it's not written, it is understood to be 1. Then we can go on and multiply them together. So in the numerator, we're multiplying the x minus 5 by 7. Now, a lot of the times we do these multiplications on any of these here, especially with simplifying a single term and expression, and we don't have anything else being added or subtracted into the numerator, we can just leave it. We don't have to multiply through. Because here the 7 times x minus 5, we can actually leave as 7 times x minus 5. Because if we did multiply the 7 through, well, we're going to have to factor it right back out later for it to be able to simplify. And we also don't have anything added or subtracted in another expression that we have to combine it with. Since it's going to be the only term, well, we can just leave it alone. Now in the denominator, we have 1 times x cubed minus 5x squared. Well, that's going to stay x cubed minus 5x squared because the multiplication of 1 is not going to change anything. Now the denominator is factorable by factoring out an x squared. Because if we factor an x squared out of both terms, that's going to turn our x cubed into x minus 5. Because an x squared out of x cubed leaves us with a single x. And if we factor an x squared out of 5x squared, we're left with 5. That does give us something in common on top and bottom, which would be the and x minus 5, which leaves us with what? 7 over x squared. And that's it. Put it right there. Thank you. Thank you, and thank you. Any other questions on this here? All right. If there are no other questions, we'll go on to look at the next one. Now looking at this one here, out of the 4 expressions, because we have 2x, x plus 2 squared, 6x squared, 3x, and x squared minus 4, will any of these factor? X squared minus 4, yes, that's one's going to factor. And we'll need to factor it eventually. But we can go on and do the multiplication first if we want. Or do y'all want to factor first? Doesn't matter which. We can go on and multiply, because if we multiply the numerators, we would get 3x times x plus 2 squared. If we multiply the denominators, we would have 6x squared times x squared minus 4. And again, in both cases, we don't want to distribute through, because are we actually going to need to add or subtract anything to these? Well, no. So we can leave them as they are. As if we did multiply through, we would have to factor it right back out. Now the x squared minus 4 will factor, because it is a difference of perfect squares, and it would factor to what? X plus 2 and x minus 2. Now let's see what simplifies. So x plus 2 on bottom and then x plus 2 on top, yes? Yes. We have 2 of the x plus 2 on top because of the square. So really it's taking this 2 and making it into a 1. So with the x plus 2 squared, we do need to be careful that it only cancels out completely if there's 2 on top and 2 on bottom. So that does tell us that we will still have an x plus 2 on top. Will anything else simplify? 3x and 6x. Well, the 3 and 6 will simplify to 1 over 2. So we will have a 2 in the denominator. We don't have to write the 1 in the numerator because we will have at least an x plus 2. And the x over x squared would simplify, because this x will cancel out one of these here, leaving us with 1x on bottom. Because we can subtract the numerators, the 2 minus 1, which would give us 1. And since it's bigger on bottom, it'll stay on bottom. And the only other thing we have left is the x minus 2. And that there would be the final answer. Any questions on any of this here? You feel comfortable with these here? Hopefully they're making a little bit more sense or a little bit easier second time round. Okay. Let's look at this one here. Looking at these two expressions in our 4 parts, the 2 numerators and 2 denominators, are any of these not going to simplify? Well, yes, there's only one that actually does simplify, which is the 8x plus, or 8x in the negative 4. Now our first real step would be to multiply them together, yes? Which is just really rewriting them and put them next to each other, yes? So if we want to make it a little bit easier on ourselves, isn't this really what we have when we multiply? Is there anything that'll simplify? Which would be what? If we do see something that simplifies, might as well go on and simplify it. Now let's see what that leaves us with. 8x minus 4 over well, the numerator does have a greatest common factor of 4. Because 2 would work, but it just wouldn't be the greatest. Because if we factor a 4 out of 8x, we get 2x minus 1 over 2x minus 1. Well, at this point here, 2x minus 1 and the 2x minus 1 would actually cancel, leaving us with 1. And that's it. So a lot of the times if we can simplify out at the beginning, might as well, because it might make things a little bit easier to work with. All right. We'll look at this one here and then we'll move on to division, because I feel like at this point y'all are feeling pretty comfortable with these here. Now we look at this one here. Well, all 4 of these will factor. So we just need to pick which one we want to factor first and then go from there. So which one of these do y'all want to factor first? X squared plus 6x plus 5. So we'll have our 2 sets of parentheses. Since the 5 is positive, the signs are the same, and they match the sign of the middle term, be plus and plus. Now the factors of x squared are x and x, 5 and 1. Okay. And I agree, I think that one would be the easiest one out of the 4 to start off with. Only one set of factors for each, so, and it does work out. Which one do we want to look at next? 2x squared plus x minus 1. Well, here, since the 1 is negative, our signs are automatically opposite. One's going to be positive, one's going to be negative. Now, the factors of 2x squared, well, we'll have the x and x, and then we'll also have a 2 and a 1. Where do we want to put the 2? Positive. We can put it here. And all the factors of 1 are 1 and 1. Now, since we do have some different combinations, we can go on and check it just to make sure we do have it set up correctly. 2x times negative 1 is negative 2x. Plus, well, 1 times x is positive x, which will give us a negative x. Correct number, but wrong sign. So what we need to do is to change the signs. Make the first one negative and the second one positive. Which now if we checked it, 2x times 1 is going to be positive 2x. Minus x gives us a positive x, which is exactly what we wanted, yes? And it is kind of nice because now in that second rational expression we have 1 on top and bottom. And x plus 1, yes? Well, those are going to cancel out. They're already gone. Which one do we want to look at next? 2x squared plus 7x minus 15 or 4x squared minus 8x plus 3? Doesn't matter which, we're going to have to do both of them. Might as well go with the numerator. 2x squared plus 7x minus 15, yes? And we're hoping one of these is either going to match up with the 2 we haven't done yet, or the x plus 5. Now, since the 15 is negative, we know the signs are opposite. One is positive and one is negative. Now, if we look at the factors of 2x squared, well, we know we'll have x and x and then 2 and 1. Where do we want to put the 2? With the plus or with the minus? The minus, yes. Because if we're going to have something that simplifies, it'd be nice if the x plus 5 on top and bottom. We had an x plus 5. Well, what are the factors of 15? Well, 1 and 15 or 3 and. Well, keeping with that thought, if it worked out that it was x plus 5 times 2x minus 3, that'd be nice. Because then the x plus 5 on top and bottom would cancel. And if we check this here, x times negative 3 would be negative 3x. 5 times 2x is plus 10x, which gives us a positive 7x. Is that what we wanted? Yes. So that factored correctly. And we kind of got there by using some of the other factors in the denominator to match up with the numerator. Okay, let's look at the last one. Since the 3 is positive, our signs are the same and match the sign of the middle term. Negative and negative. Well, the factors of 4x squared will have x and x. Now we need to decide, do we want to use 1 and 4 or 2 and 2? What do we think? 2 and 2, because in the numerators, there are 2 different places where we do have 2x. We don't have any places where there's a 4x. So most likely we're hoping it's 2 and 2. And well, the factors of 3 are 3 and 1 or 1 and 3. And if we do check this, 2x times negative 3 is negative 6x. Negative 1 times 2x is negative 2x, which does give us a negative 8x, which we wanted. Exactly. So what's going to cancel out at this point? 1 and 2x minus 1. 2x minus 3 and 2x minus 3. X plus 5 and x plus 5. Which leaves us with 1. Because anything divided by itself is 1. So really this entire expression ended up being divided by itself, which reduced us to 1. And that's it. Questions on this here? I find these to be some of the more frustrating, especially when it takes you a good 5-10 minutes and it all reduces to 1. I mean, heck, I'd like it to be a little more complex, especially if I put a lot of time into it. So do we feel comfortable with multiplication, especially going over it again? All right, let's look at division. So, looking at this here, can I simplify the z in z cubed at this point? Okay. Well, what is the first step in dividing fractions? we change it from division to and flip the second. So when I do that, are the z's still on top and bottom? Well, no. The z and z cubed are actually now both in the denominator. So we can't actually simplify those out or simplify them down. Because it actually works out that z times 5z cubed is now 5z to the fourth. And in the numerator, we're going to do what? 7 times 3, which is 21x cubed. Now at this point here, will 21 over 5 simplify? No. X cubed over z to the fourth won't simplify because they're not like terms. So that's it. Any questions over any of this here? Let's go on and look at the next one. So this one here, we will have some things that factor. X squared minus 9 actually turns out to be the only one that does. But before we do any simplifications or simplifying anything out, we really need to change it from division to multiplication. So we can leave the x squared minus 9 as it is, and it's going to be over x plus 4, times, here we're going to have x plus 4 over the x minus 3. And now we're going to do almost the exact same thing as we did previously with multiplication. That's one thing that we'll know will happen eventually. The x plus 4 and x plus 4 are going to cancel. Because if we left them in there, it's just been x squared minus 9 times x plus 4 over x plus 4 times x minus 3. Well, we can get rid of them now, might as well. Really leaves us with x squared minus 9 over x minus 3. Exactly. The numerator is the difference of perfect squares, so we'd have x plus 3 times x minus 3 over x minus 3. Well, the x minus 3 and x minus 3 will cancel out, leaving us with x plus 3. So in the end, is division really any different than what we did for multiplication? Well, no. Except for the first main step of changing from division to multiplication, flipping the second, it really doesn't change anything. So looking at this one here, well, the numerator won't change, x squared plus 8x plus 15 over x squared times what over what? 1 over x plus 3 squared. And then we will multiply them together. Now the denominator is going to be x squared times x plus 3 squared. And we don't have to distribute that x squared, and we actually couldn't in this form, because the x plus 3, how many of them are there? 2. For me to be able to distribute the x squared into it, I would actually have to rewrite it as plus 3 times x plus 3 to be able to multiply it in. Because that constant term out front can only go into one of them, it can't go into both. Unless we wanted to multiply each one by an x, then it could. But because it's only one term, we're going to leave it. Because if something's in common on top and bottom, it's better to leave it as x squared times x plus 3 squared. Well, the numerator would be x squared plus 8x plus 15. Essentially, we multiplied with the 1, but multiplication of 1 doesn't actually change anything, which is kind of nice. But we still need to factor, just in case there is a like term on top and bottom. And this would work out to be x plus 5 times x plus 3. Because since the 15 is positive, the signs are the same and they match the sign of the middle term, which would be plus for both. Factors of x squared are x and x. Factors of 15 that we want are 3 and 5. Because our 3 plus 5 would add together to be our 8x. X plus 3 on top would cancel out with 1 of the x plus 3's on bottom. And exactly, we'd be left with x plus 5 over x squared times x plus 3. And that's as simplified as it gets because, well, the x plus 5 is one term, and it won't simplify with the x squared. Any questions on any of this here? So again, this will be the last one we'll look at for division because I think just doing a few of these here that we've done, and this one I think is going to be helpful enough for getting this firmed up if it wasn't already. Now the first thing we can do is rewrite this. And change it from division to multiplication and flip the second. Now, if you do feel comfortable with this here, and when I say comfortable, feel comfortable enough without that you know you won't lose factors or kind of drop things, you could have gone on and started actually factoring at this point. Because a lot of times when I solve these here, I do change it from division to multiplication and factor the ones that I know I can factor pretty easily. So the 3x squared plus 2x minus 8, I would already have factored it. Or, since the two numerators do have a greatest common factor, go on and pull that out in the same step. But if you feel like there's a good chance you'll pull out the greatest common factor or miss some of those parentheses, go on and rewrite it first. And now we can go on and do that step. Now the 3x is going to stay 3x because it's a single term. Now looking at the 12x squared minus 22x plus 8, the greatest common factor that we can pull out is what? Well, 2. Because 2 will go into all three. It might be very tempting to say 4, because 12 and 8 both have a greatest common factor of 4, but unfortunately 22 does not, so we can only pull out a 2, which will leave us with 6x squared minus 11x plus 4. Now the other numerator, the 2x squared plus 4x, does have a greatest common factor, which is 2x. And if we factor it out of 2x squared, we're left with x plus 2. So it worked out the two numerators both had a greatest common factor that we can pull out. What's kind of nice is that the 2x squared plus 4x actually is simplified as it gets. We don't have to do anything else with it. Now the 3x squared plus 2x minus 8 will factor, and there's not a greatest common factor, so we can go on and do the two sets of parentheses. Now since the 8 is negative, our signs are going to be opposite. One's going to be positive, one is going to be negative. Now we need to look at the factors of 3x squared. Well, we'll have x and x. We'll put the 3 with the negative. And then 2 and 4. Exactly. So Colton, why do you want to put the 3 with the negative? Yes, because we want a middle positive term, yes? So we want the bigger number to be positive. And well, with our x's, one of them's 1, the other is 3. So whichever one multiplies with the 3 is probably going to give us a bigger number. And if we want it positive, we need the 3 in a place where it's going to multiply with a positive, so we can put it with the negative. Now we can check it to make sure. X times negative 4 is negative 4x. Plus 6x is 2x. What is the factor in the numerator for that one? Because inside the parentheses we have what? X plus. So it'd be nice if one of the denominators had, which that would give us it. And realistically, all these are going to cancel out. Might as well, since they're right there and it's easy to cancel out. So that leaves us with factoring the 6x squared minus 11x plus 4. On the other one, we're just left with 2x over 3x minus 4. We can put the parentheses around the 3x minus 4 just to remind us that those two are stuck together. What are we hoping one of the factors for the 6x squared minus 11x plus 4 is? 3x minus 4. Because if it is one of those, they will cancel out. Since the 4 is negative, our signs are the same and match the sign of the middle term, which would be negative and negative. Well, the factors of 6x that we have are 1 and 6 or 2 and 3. But we also have the x and x. So do we want to use 1 and 6 or 2 and 3? 2 and 3 because it's going to guarantee or have a greater possibility that one of them is 3x minus 4. Well, the factors of 4 are 1 and 4 or 2 and 2. And 4 with the 3, exactly. Because if we want something to simplify, we do need one of them to be 3x minus 4. Now we can check it to make sure that this does work out. 2x times negative 4 is negative 8x. Negative 1 times 3x is negative 3x, which gives us a negative 11x, which is exactly what we wanted. Which means we can go on and multiply these together. Almost. Well, we do have a few things that cancel. One of them is 3x minus 4. Is there anything else? 2x and 3x, but not quite the whole thing. It's just the x and x would cancel out. Because the 2 and 3 are not divisible by each other, because they're two terms being multiplied together. Now in the numerator, we are left with the 2 and 2, which multiply together to give us 4, because they're single terms. We have times 2x minus 1 all over 3. And that's what we get here. Any questions on any of this here? Now we do have the rational expressions, and we're running a little short on time, so we'll save those for tomorrow.